Hello everyone, welcome to Coders Camp. We are at 8th day of June Leetcode challenge, and the problem we are going to cover in this video is construct binary tree from preorder and inorder traversals. So the input given here is two integer arrays where preorder array represent the preorder traversal of a binary tree and inorder represent an inorder traversal of a binary tree. From these two arrays we have to construct a binary tree and return the root of the tree node. So let's understand this problem. How are we going to approach this? So here is a given input. The first array is preorder traversal, and we know preorder traversal of a binary tree is nothing but visiting the root node first and then the left node and then the right node. So now if you consider this preorder traversal and try to construct a binary tree, we know the first ever node is going to be the root node of our tree. Directly we can put 3 as a root node. The rest of the integer values in preorder traversal array is going to be the left and right subtrees of our root node. So now if suppose we are trying to put up these values in a binary tree, it can be having 9 as the left node and 20 as the right node, as this one is going to visit the left and right child, or it can also be represented like this, that is both 9 as well as 20 can be in the left node, and 15, that is the next element in the array, can be the right node, or all the elements, that is 9, 20, 15 and 7 can be the left node children. So we cannot predict our binary tree is going to be like this only by considering the preorder traversal. So here comes the inorder traversal for the help. So here inorder traversal, we know we are going to visit the left nodes first and then coming to the root node and then the right nodes first. So in that case, if you consider the inorder traversal of the same binary tree, where is the root node present? That is, our root node is 3 here. So we are going to search the index of our root node in our inorder. So if you search, 3 is somewhere here in the first index, which actually means by the inorder traversal, all the left nodes or the left subtree of the root node are going to be towards the left side of the array, and the right subtree is going to be the right side of the array. So in that case, 9 is going to be in the left subtree and 20 is going to be in the right subtree. So obviously the second approach or the second formation of the binary tree is not valid. We can cancel it out. So it possibly can be the 9 is the left node, that is correct, but we still have to figure out whether 20 is the right node or further we have any other right subtree left. So by using these concepts, we are going to construct our binary tree and return it. So let's get into how actually this is going to work. So now we are going to create the tree nodes from the preorder traversal, starting from the very first index and towards the end. And we create every node till the last value in the preorder, and we are going to identify its position and its children's position based on the value of inorder traversal. So let's start constructing our tree first. As we know, our first node in our preorder traversal is going to be the root node very clearly. So we are going to put that in our as a root node. Here comes the question that where can we place its left and right children. So now we are going to check where the root node's value exists in inorder. So it exists in the index 1. So we can define or find out that what are the values left to the root node is going to be the part of left subtree, and what are the values towards the right of the root node's value is going to be part of the right subtree. So we are going to first construct the left subtree by calling the values from the first index of inorder, that is from 0 to 1 index before the current node. Let's have this root node is our current node. So before the current node index, what is left is going to be the left subtree. So we are going to iterate the first half to construct our left subtree and then move on to the right subtree. So now it is calling or passing 9's position. So it goes here, and 9 is going to be the only node present. So obviously it is going to be the left child. So we are placing our 9 as the left child of our subtree. So our left subtree is done. Let's move on to the right subtree, which is having 3 values. So here we need to again find the root node, and from the root node we have to construct its children. So we are passing this range, that is after the current node index till the end of the inorder traversal. So here it goes and checks the next value. As we know, our preorder traversal is going to form the root, left, and then right. So now root is done, left is done. Next, the root of the right subtree is going to be 20. So this is the starting. So this is going to be our head of, or the root of the right subtree. So we put that as a root of a right subtree, and we are going to find again the index of 20 in our inorder. Index of 20 is here. So we know what is left before 20 is going to be the left subtree, what is left after 20 is going to be the right subtree, because we are done with 3. So what is left before 20 is 15. So that is the only element. So we are going to place that as our left child, and 7 is the only element after 20, so that is going to be our right child. If suppose we have value after 20, some 3 values, that is 3, 5, 7 and 6, 8, then after 20 we found our child 7 as our right child, because in pre-order it is going to be 15 as the left child and 7 as the head of the right child. Once we found 7, what is left before 7, that is 3 and 5, are going to be part of its left subtree, and 6 and 8 are going to be part of its right subtree, and it goes on like this. So as we are going to find the index of our pre-order node in inorder array and define its left and right subtree, it is happening again and again. So we are going for a recursive solution. So here, to help us, our recursive solution is going to have a helper method which is going to pass obviously the preorder and inorder arrays, and the starting index of our inorder and ending index of our inorder and starting index of our preorder array. Why? Because we are going to construct our binary tree based on the range of our inorder, that is from where to where our left subtree and where to where our right subtree exists. To find that, we need to have the index of starting and ending index of our inorder. Same way, we are going to create the nodes starting from the 0th index towards the end of the preorder array. So which index we are working on, or which node we are creating right now, will be pointed by our index of our preorder array. So everything is going to be the same way, that is we are going to call the recursive function by keeping the left and right subtree before and after the found index. But here the question is, where do we find the left and right node exist in preorder array? To do that, obviously we know after root node, the head of our or root of our left subtree is going to be there in our preorder, because once root node is visited, the very next node it visits is going to be its left child. So if we find our current index is going to be the current index of the root node, then current index plus 1 is going to be the index of its left child. But how do we find the index of the right child? That is the question here. In preorder traversal, once we visit the root node, we are going to visit all its left children, whatever is there left in the left subtree, and then move on to the root of the right subtree. So we know after the left child, it is going to have all its children or all the elements of its left subtree, and then move on to the right child's root node. So to find the right child's root node, we are going to pass the current node plus size of its left subtree, so that once current node and size of its left subtree are over, it is going to visit the, or it is going to have our root of right subtree at that index. So now the question is, how do we find the size of our left subtree? So if suppose we are having 20 as our right subtree's root node, then the size of the left subtree is going to be from 3, that is from the root node, what is there in the left side of the array is going to be size of the left subtree. So we are going to add the current node, start from where we are starting. We are starting from the first ever index, that is index 0, that is going to be the root node. From the root node, we are going to add size of our left subtree, which is nothing but what is left before 3 is going to be the size. It is going to be only 1. So size is going to be only 1. So after plus 1, after this is where our root of our right node. So hope you're getting this. Hope you're understanding the solution as well. So this is going to work in big O of n time, as we are calling the recursive function for the number of nodes present in the binary tree. So let's go to the code now. So yes, as I said, we are going to have a recursive function. So let's directly write the function, which is going to have the starting index of our preorder array and starting and ending of inorder array, and both the arrays as arguments. So first let's check the basic conditions, whether our index is out of range, that is the edge cases, then we are going to return null. Now we are going to create a root node which is going to have the index of our preorder array, because we are starting with that, and we are going to iterate our inorder array and check where is our value exist to find its left and right sets. So now we are doing a simple loop to check and assign the index of that from in order in current index variable. So our left child is going to call the same function from the range in order start to where is our current index -1, because our left subtree is going to lie there. So again I'm going to call the same function for right subtree, but again from the range current index minus in order will give you the size of our left subtree, and this is going to be from current index +1 to end of the in order array. So finally return the root. So this is it. Our main method is going to simply return what is our helper method is going to return, and we are going to start it with 0th index. So yes, let's run and try. Okay, so let's run. So let's submit now. Yes, the solution is accepted. And runs in 7 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.